Okay, let's see, where did we leave off? Trig, wasn't it? No, I remember we've done up to 196. So let's have a look. Maybe we can get the page finished. Let's see. Right. Find all values of x on the graph of that function where the tangent line is horizontal. Okay. So 197, you have y equals, or I should rather say fx equals minus 3 sine x cos x. So the derivative of sine is cos. So it's minus 3 cos squared x. And then the derivative of cos is minus sine, plus 3 sine squared x. And you want that to equal 0. Dividing by the 3 and taking this to the other side, we get sine squared x equals cos squared x. So basically that's when sine equals cos, or we could say when tan squared x equals 1, which would mean when tan x equals plus or minus 1. So it's 45 or minus 45 or pi over 4. So that means x equals pi over 4 or minus pi over 4, but also every multiple of 180 as well would work. So plus 180, or sorry, pi n, and plus, n pi, where n is an integer. I think that would be all the situations. Let's check the answer at the back actually for it. I wonder if they really do mean all of them. 197. They clean it up into 1. Can we put it into 1? That would be a half pi plus a quarter pi. Yeah, maybe we could put this into 1. So the top one would be 4 n pi plus pi over 4, and the bottom one would be the same thing, 4 n pi minus pi over 4. So we could take this, how do they do it? They take the pi just out, and they have a 2 rather than a 4. So what might be clearer is if I just list the angles out. So this means you could have, for example, with the plus 1, you could have 45 degrees, or 45 plus 180, which is 225, or plus 180 again, which is 405, etc. Or also you could go backwards. So you could have minus 135, minus 315, etc. And then you could also have minus 45 going forwards. Minus 45 plus 180 is 135. Then plus 180 again is 315. And then you could have minus 45 going backwards. Minus 225. Minus 405. So if we try and list them out, let's see, we've got 45. And then the next one after 45 is 135. And then the next one after 135 is 225. And then 315. Then 405. Then backwards is minus 135. And then minus 225. Yeah, we're the minus. Oh, and I sorry, I didn't write in the minus 45. Minus 45 and 45. Yeah, okay. Yeah, they're going up in 90s. So it's 45 plus 90 degrees n, where n is an integer. So if we write that in radian form, that'd be pi over 4 plus pi over 2n. So that would be all over 4. And this would take the pi out. And then that's like 2 plus 1. And sorry, the 1. So it's 2n plus 1. Is that what they have? Yeah, it is, where n is an integer. All right, it's actually harder than I thought just to list all the answers in a nice compact formula. But that's it there done. Okay, so that's taken care of. 198. Find all x values on the graph where where the tangent line is a slope 2. So that's much easier. The derivative here is 1 minus, so plus 2 sine x, and that should equal 2, which means 2 sine x should equal 1, which means sine x equals a half. And there's two answers here, one in the first quadrant and one in the second quadrant, and there's a symmetry between the answers. And sine inverse a half, that's the classic 30 degrees, or pi over 6. So then this is pi over 6 away on the flip side. So that's 5 over 6 pi. So the two answers, pi over 6 and 5 pi over 6. And you know, we can check the answer, because if I type in 1 plus 2 sine pi over 6, guess what? I do get 2. And if I type in 5 pi over 6, I should also get 2. Yeah. So that looks okay to me. 199. Cotan x, turn the points on the graph where the tangent lines are parallel to this line. So meaning slope is -2. Okay. So the derivative of cotan, remembering cotan is cos over sine. So that's sine squared. Remember, it's cos over sine for cotan. The bottom times the derivative of the top, which is minus sine squared, minus the top, which is cos, times the derivative of sine, which is cos. So that's -1 over sine squared. And you want that to equal -2, which means you want sine squared to equal 2, which is not possible. So that's a never. Ah, I saw I screwed it up. Oh, it is. Oh, Stephen. I forgot to flip this upside down. How embarrassing. A half. So that means you're trying to solve sine x equal to, I'm feeling a bit tired, didn't sleep much last night, sine x equal to plus or minus root 2 over 2. So 2 answers for each sine, so 4 answers altogether. So the 4 answers are, with the positive one, the initial answer is pi over 4. And the second answer will be in the second quadrant. So that would be pi over 2 plus pi over 4, 3 pi over 4. And then for the negative answer, that would be minus pi over 4, which is here. And the second answer would be there. So 5 pi over 4. But we don't really want a negative answer because it's between 0 and 2 pi. So to flip that into a positive answer, it would be 7 pi over 4 to go around. So that looks like the 4 answers. But they want the points. You have to get the cotan of each of these. Right, so 1, 2, 3, 4 answers here. Pi over 4, 3 pi over 4, 7 pi over 4, and 5 pi over 4. It's cotan, isn't it? Yeah. Okay. Let's get the first one. So the y value will be 1. And then the next one, the y value would be minus 1. And then the next one, minus 1. So, well, I'd be shocked if it wasn't 1. 1. Pi over 4, 3 pi over 4. But only 2 answers. So, interesting. Interesting. Why only 2 answers? Is something not work in the original? You know what? I might be doing something silly, but I'm curious to see the graph here. Try and get a better picture of what's going on. Very strange to me. Yeah. Is it possible? No, I'm not sure. Okay, 1 over tan x. Let's graph that. And I want to go up to about 6. Okay. Then the line y equals minus 2x. Let's graph that. Okay, there it is. And then let's make our tangents. So the first one is the tangent of equation 1 when x is pi over 4. Just want the tangent line here. Yep, that looks parallel. No problems there. And then the next one is 3 pi over 4. Also looks parallel to me. Okay. 7 pi over 4. There it is. Looking still parallel to me. And then 5 pi over 4. Oop, where's that one? Oh, there it is there. Yep, there are 4 lines parallel to y equals minus 2x to the cotangent graph between 0 and 2 pi. Am I missing something in the question? Let fx equal cotangent x, determine the points on the graph of f between 0 and 2 pi where the tangent lines are parallel to that line. And yeah, it only lists 2 points. How peculiar. Let me pause the video to see if there's any notice on their website about an error to the answer. Okay. So, yes, I've seen on their website that the domain should be shortened to 0 pi or the answer should include that. Now, what's confusing me is it says that this was corrected in spring 2021, but I don't think it has been, because so I can get the date of this one. Uh, mm, what what version is this one? Is it 2020? How could I find out the version number? I don't think it's been corrected. I don't think it's been corrected. All right, so where am I now? Yeah, yeah, it hasn't been corrected. So maybe I should open a ticket up to see what's happened. So we are correct. So 199, we've got a problem. How are we doing for time? Okay. Well, the next one's a technology question, so that's handy. Okay, so what have we got going on here? A mass in a spring bounces up and down according to this function. Minus 6 cos t, where s is measured in inches and t is measured in seconds. Find the rate of oscillation at 5 seconds. Okay. Right derivative. And then sub in 5. There we go. Yeah. Okay. 201. Let the position of a swinging pendulum modeled by that equation, where a and b are constants, t is measures time in seconds, and s measures position in centimeters. If the position is 0 and the velocity is 3 when t is 0, find the values of a and b. Okay, so a cos t plus b sine t, that's the position function. The velocity function would be minus a sine t plus b cos t. The position is 0. Initially, so s is 0 will be a cos 0, which is 1 plus b sine 0, and that's equals 0. Okay, well that's nice. So we got the a, and then and the velocity is 3 when t is 0. The velocity is 3. So again, velocity at 0. Well, we said a is 0, so that's 0. And then that's b, and that will equal 3. So, yeah, a is 0, b is 3. Is it as simple as that? Is it as simple as that? 201. It is as simple as that. Okay. And lastly, after a diver jumps off a diving board, the edge of the board oscillates with position function. Okay, 202. St equals minus 5 cos t. So initially negative. Yeah, sketch one period of the position function for t greater than 0. So one period would be up to 2 pi seconds. This is the s in centimeters, and this is the time in seconds, and this is 2 pi. And we start off at minus 5, and it goes up and down like that. Okay. Find the velocity function. So the velocity function will be 5 cos t. 5 sine t. Now we want to sketch one period of the velocity function. That's the velocity in centimeters per second. And this is the time in seconds, and that's 2 pi. And the velocity starts at 5 and goes down. I should really mark that off as 5 there, and goes down to minus 5. And it's like that. Okay. That's C. D. Determine the times when the velocity is 0 over one period. Well, that's here, here, and here. If you want to include the 2 pi, some people do, some people don't. So it's 0 seconds, pi seconds, and maybe a lot of people like to use the domain 0 to 2 pi, so you're not kind of counting this twice, so to speak. So I'm kind of tempted to do the same thing here. They're kind of intervals like this, but you determine the times when the velocity is 0 over one period. Yeah, depends if you want to include the 2 pi. Maybe you don't feel like including the 0 since at the beginning. I think if there was an answer at the back, I'd hope it'd go for these two. Find the acceleration function. The acceleration function is 5 cos t. And sketch one period of the acceleration function. So acceleration in meters per second squared. That's a 5. That's a minus 5. That's a time in seconds. And the 5 cos graph will look like that. Okay. Yep. That will be a good point to wrap it up. Yeah, I don't have an answer for 202, but oh well. So where are we going to next time? Next time we're nearly finished. We'll get this. We should hopefully get this finished next time. And then we're on to the chain rule. rapidly approaching the midpoint of the book. How exciting. Okay, we'll leave it there for today. Thanks for watching, and I'll see you next time.